in this question there is to find the element forces means what are the forces in this element, in this element, in this element. So up to now we have got a nodal forces acting at node 1, node 2, node 3, node 4. F1, F2, F3, F4, F5 is known to us. So if I have to write for element 1, for element 1, the free body diagram is, it is like that: node 1, node 2, element 1, and this force F1, I write a small f1. This is actually equal to capital F1 that we derived here itself, because there is only one node. Contribution for one element is coming on that particular node. Here F2 here is a resultant force. This global F2 is a resultant force due to this element and due to this element, because both are connected. Okay. So in that case, elemental force I need. So I write, okay, elemental force F2 is what? Due to element 1. This is the case. The finite element equation, finite element equation of element 1, this one, F1, F2 equal to K value is 200. So 200 minus 200 minus 200 and 200, this, and this is U1 and this is U2. U1 is by default equal to global, and that is 0 here in this case. U2, you know that net resultant nodal displacement for this element or that element must be one and single value. So that is U2, capital U2, and that value we have already calculated, that is fine, that is 0.005. So if you look at this implies F1 is the nodal force that we have already calculated here, but just want to check it as well. F1 equal to 200 to 0 minus 200 into 0.005. So that coming to minus 1.0 kilonewton. Either you derive it or simply I can write it is equal to capital F1. So this is nothing but capital F1. And F2 is due to element 1 is equal to 200 into minus 200 into 0 plus 200 into 0.005. So that is plus 1.0 kilonewton. So this is the elemental force at node 2. Elemental force at node 2 due to element 1. Correct? If you look at F2, net F2 is 0. Net external force acting on node 2 due to global positioning is 0. Capital F2 is 0. But nodal force at 2 due to element 1 is F2 1, that is 1 kilonewton. So similarly, you can find it out, the nodal forces in element 2, nodal forces in element 3, nodal forces in element 4. So that way you need to determine the elemental forces in the different elements.